2. So welcome back. We are now in the end of week 7. This is our 13th lecture, and we are continuing to review on for the test. And we're in the workbook, and everyone should hopefully see this, producing data sampling. So what is the goal of sampling? Obviously, we take samples because we want to infer something about the entire population from the sample. And we have different methods of sampling and different problems with sampling that we want to avoid as best as possible. So number one, let's assume I have a crazy idea. I will give an A as a final grade to a few randomly selected students in this class. I have a few ways to select these lucky students. Identify my sampling method for each. Method 1, I randomly pick 5 students from the roster. Assume that's perfectly random. What kind of sampling technique is that? That is, sorry? We're doing 8 first. We're going to go 8 to 9.
Would that be SRS?
That will be an SRS, a simple random sample. B, I randomly pick 5 females and 5 males. What kind of sample is that?
What page is that?
We're on page 62.
62. I thought I said that. If I forgot to, I'm sorry. 62. You randomly pick 5 males and 5 females and 5 males.
Stratified sample?
That's stratified. You divide them into 2 groups and then pick an SRS from each group. That's stratified. I randomly select 1 freshman, 1 sophomore, 1 junior, and 1 senior from the female students, and 1 freshman, 1 sophomore, 1 junior, and 1 senior from the male students.
Stratified random sample.
It's also stratified. This one, you might actually throw in an extra thing, which is like a multi-stage sampling. But at the end of the day, it really is stratified because you're basically dividing it up into female freshmen, female sophomores, female juniors, female seniors, and so on. Question 2. For the following situations, identify the sampling method, including whether or not random sampling was employed and potential sources of bias or any other problems. A, an online magazine asks its readers to vote on whether they thought that a 4-day work week would hurt the economy. What sampling method is that?
Voluntary.
Voluntary response, excellent. Was it random?
No.
Not even close. Are there any potential sources of bias or any other problems?
Yes.
Yeah.
Yes. I mean, it's just, yeah, clearly. Okay. Okay, B. The Bureau of Labor Statistics researchers randomly selected 500 individuals from each of 9 geographic regions in the United States and asked each one if he or she was employed full-time. What method?
Saturated random sample.
I'm sorry, say it again, please.
The saturated random sample.
What was the word you said first? Oh, stratified.
Stratified.
Yeah, sorry, I didn't hear that. Stratified random sample.
Yeah.
Is that random?
No, because they selected geographical location.
Yes, but within each geographic location, was it followed up with a random?
Yes.
Oh, yeah.
Yes, so it is random. It's just not an SRS, but it is random. Any bias there?
Yeah.
Or any other problems?
No, as long as it actually does encompass the whole United States.
Yeah, I don't see a problem there. Exactly. I mean, just the usual problem that would be for any sample. You know, I mean, who did they actually answer and stuff like that. See, pollsters called 1,000 randomly selected phone numbers to ask the callers' opinions about radio stations.
SRS.
No, it's definitely not an SRS
Wow.
because only people with phone numbers can be called. Right? Not everyone can be reached this way. Do you agree?
True.
So it can't be an SRS.
Would it be voluntary?
Well, it's not voluntary because the people for voluntary, I have to decide on my own to, play a role. And here they're calling me.
Oh, okay.
So it's not voluntary. It's,
Random sample.
huh?
Would be the stratified random sample.
No, it's not stratified. Where is the breakup of into groups,
Because you're, yeah, you're right, you're right.
right? So
Yeah.
this one is the book. The book has a bold-faced, version of sampling called phone sampling. But phone sampling is not really its own category. It's just a type of sampling. This is really convenience sampling more than anything else, where you just pick random numbers and call them because it's easy to do so. I would put this as convenience sampling, and it's biased because there's no way of getting the entire population this way. Agreed or not agreed?
Agreed.
Okay. 3, you need to gather students' opinions about the cost of parking for students on campus. It's not practical to ask all the students, as there's 40,000 students. Give an example of a way to choose a sample of students that's a poor design because it depends on voluntary response. You have a poor design because it depends on voluntary response.
Like when they do like the email,
The what? The emo?
the email.
Oh, the emails. What do you mean by that? Be more specific, please.
Like sometimes like when they send out like the emails, like, oh, like give us like rate how this, and like when you go to the bookstore, and then like they ask for your number, and then they ask you to like rate how your experience was. You could do like that.
Okay. So I think it's a great one, actually. You go to the bookstore and they have a receipt. On the receipt's a number that says, call in or email us. So your opinion. I think it's a great one. That's a great poor design because it's voluntary response. That's wonderful. I was gonna, I thought of like, putting a flyer on the wall that says, call this number for this reason or that, whatever. But yeah, yours is wonderful.
I was thinking,
Yeah.
you
Huh?
could you could put a survey up on the portal and just
Yeah. Put a survey on portal and see who bothers to respond. Another great example. B, give another example that does not use voluntary response, but is still a bad way to sample.
Or
only
like your, oh,
go ahead.
like if your professor makes you do like the survey,
Um,
like if they're like, oh, you had to do the survey because it counts for a grade.
well, are you saying that you wouldn't be honest because he's making you do it? I mean,
I'll be honest.
that's a whole nother issue. But actually, if every professor did this for every one of their students, I think that would be an amazing sample because that will get the entire population. Right?
Maybe using people who already bought the parking pass.
Wait, so what do you say? To do what?
Like only choosing students who bought the parking pass. Like,
Okay. All right. So you have a systematic sampling. It's a very systematic way of getting people. That's not random at all. But you're only asking people who got it, so they might be very biased towards hating it because they had to pay money for it.
yes.
Something like that. So yeah, that's wonderful. C, give at least 2 valid ways of sampling. Unbiased methods for sampling students' opinions.
What Lorena said prior, have a teacher make everyone do the
Okay, so that gets the entire population. So that's a wonderful way of sampling because it's the biggest sample of all. What's one that doesn't give me the entire population? What's another way of doing it that's valid and unbiased?
If you like go up to people like when they're walking.
Well, the problem with that, which is taking a survey, is you get to choose who you're going to approach. And you might approach them based upon how they look, how they act, and that's not really random. But yeah, go ahead.
possibly like going in different like places, different parking lots, and then asking like the second car.
Okay. So taking different parking lots in the second car, but of course, wait a second. Now we're only looking at people who drive to campus. What about people who commute? They might have different opinions about the cost of parking on campus if they don't actually park there, right?
Yeah.
So what you can do is you can go to the library and ask, every 10th person who comes in, because people who go to the library just as likely to be driving as not driving. There shouldn't be any bias in that direction. And it's systematic in the sense that you're not asking who you want, but every 10th person you ask, you could, get some kind of, no, I probably can't do it that way. I was going to say, get like a listing of every student on campus, putting them all in a box or in a computer box and picking out people at random. I'm not sure if it's possible to, for ethical reasons to do that or not. But anyways, there are other things that I'm not thinking of, but that's it. That's chapter 8. Chapter 9. Now we do experiments. That was sampling. Now we do experiments. So what's the difference between an observational study and an experiment?
An experiment is more controlled, whereas observation, you don't really have control of all the variables.
Actually, you have control over no variables. It's not just some of them. You don't have any control whatsoever because you're basically observing after the fact, right? Right? You don't have control over anything. You can just say, here's what happens. Right?
Yeah.
B, what is the critical advantage that randomized controlled experiments have over other experiments and observational studies? What is the critical advantage?
I think one of the advantages to a controlled experiment is like you'll give it more attention than because you want like a certain outcome.
Well, let's assume that you're as a statistician, you're being ethical and you're giving the same attention to each. There's still a huge advantage that randomized controlled experiments have over others.
You can kind of isolate variables, whereas other.
That's exactly it, right? You can basically you can design it to have lurking variables and other influences which might confound the experiments. So you can focus on hopefully some kind of cause and effect relationship. You can't do that for observation, right? If I'm observing, pregnant mothers who drink while they're pregnant, there could be 1,000 other things that they do. They could be smoking, they could be doing drugs, they could be doing this, they could be doing that. I can't control any of that because all I am looking at is the observations that I'm noticing. 2, a food company assesses the nutritional quality of a new instant breakfast product by feeding it to newly weaned male white rats. In this experiment, they used 30 rats and compared the new product with the standard products. After 28 days, they measure the rat's weight gain. What is the explanatory variable? What is the response variable?
The response variable will be like the rat's weight.
Yeah, the response variable will be the weight, or specifically the weight gain. Right? The response variable is the weight gain. That's what they're measuring. And what is the explanatory variable? What is their claim that's causing this response, or at least that's correlated to this response?
Like the instant breakfast.
So what's the variable?
The nutritional quality.
Not exactly. Remember well, yes, in a sense. But in this case, the variable is which product they are using. There's the standard products, and then there's the new product, right? They're varying the products and measuring the weight gain, right? A variable has to be something that varies, right? What exactly are they changing to measure what response? Does that make sense?
Yeah.
So it says use a diagram to outline the design of this kind of, I'm not going to ask any questions on designing outlines, but essentially what they want you to do here is something along the lines of, I have, a certain number of rats. I have all these rats. I divide them into two groups, the ones who get the new food and the ones who get the old food. And then I measure, they have this treatment and that treatment. This treatment is the new product and that treatment is the old product. And then I get my information and I compare it. That will be the design of the experiment, but I don't like questions like that. So you won't see anything like that on my tests. No measuring, nothing like that at all. So 3. We would like to study the effect that a certain medication has on the hours of sleep that people with insomnia get every night. Do we need an experiment or an observational study?
Observation.
If it's observational, then how do you control the medication?
Placebo?
Huh?
Placebo?
Well, yes, but if it is a placebo, then it's got to be an experiment.
Yeah.
Yeah, it has to be an experiment where you give some people the medication and some people you give a fake medication. Otherwise, how do you compare the difference between those who get it and those who don't? Right?
You wouldn't know.
You would know. So it has to be an experiment. Right? Now, what features should our experiment have? What are the main features that you want every experiment to have?
I guess one group of like the fake medicine and one group with the real medicine.
Well, you want to have your different treatments.
Yeah.
Okay, so you want to have your different treatments.
Make sure.
Well, huh?
Want to make sure it's random.
Randomness. Different treatments, randomness. And there was another feature that we always want.
Control?
Well, that's the treatments. That's like having the control group and the experimental group.
Okay.
We also want R, E, P, L,
Replacement?
I,
Application.
replication. What does that mean, replication? What does replication mean?
Is it like constant?
Not constant. Replication means
You can
you want to keep, I think it was called replication. You want to have lots of trials. All right. So you don't want to do this with like one person for each treatment. You want to do it 100 people for each treatment. Okay. The more people you have, the more replication you have, the more accurate your experiment can be. You want to have the control versus the experimental group, the different treatments. You want to have randomness. You want to have replication. Yes? Makes sense?
Yeah.
Okay. And again, I'm not going to ask you to draw the outline of an experiment. Okay. That's it for 9. 8 and 9 were easy. Small, non-quantitative sections that are just very conceptual. Just know your basic types of sampling and the features that we want to use for experiments, and that's very straightforward. 4 and 5, here we go. Let's have some fun. So scatter plots and correlation. So number 1, the table below shows flight distances in miles and the least expensive nonstop airfare in dollars from Los Angeles to selected cities round trip. The prices are based on the following dates. This all occurred a long time ago, 2008. What is the explanatory variable and what is the response variable? Which one, if anything, should have the effect on the other one?
Miles.
What?
Like the mile should take like, it should be a variable.
Yes, miles should be a variable. Dollars is a variable. Those are the things that are changing. But which one? This is 4 now. Chapter 4, because 4 and 5 are together, but they go in order. Which one should affect the other? Should miles affect dollars or should dollars affect miles?
The number of miles should affect the dollars.
So which one's the explanatory and which one's the response?
The response should be the dollars and the explanatory should be the miles.
Okay, the response is dollars and explanatory is miles. Are these categorical or quantitative?
Potato.
They better be quantitative because you cannot do correlation or regression if they're not quantitative. You need numbers. So it says complete the scatter plot below by adding the points for the last 4 cities and then labeling the axes. So notice that the x-axis is 0 to 3,500, and the miles obviously fall between 0 and 3,500. Airfare, these numbers are smaller. And let's just not bother adding the last ones because, well, what the hell, let's do it. The last 4. We have miles 591, airfare 179. Where should that go? Miles 591, airfare 179.
Should be in between like 236 and 843.
Yeah, so 591, 179, about that. About there somewhere, give or take.
Yeah.
Okay. The next one is 1482, 247. 1482, 247. 1482, right beneath 1500, 247. About there somewhere, give or take. Yeah.
Yeah.
And then we have 954, 178. 954, 178. 954, 178, about there, give or take. And finally, the last one, 1601, 285. 1601, 285. About there somewhere. Okay. So C, describe the relationship between flight distance and airfare using the scatter plot. Make sure you mention direction, form, strength, and outliers. What's the direction?
Positive.
Positive. What's the strength?
Moderately linear.
Certainly seems moderate to me. Again, the numbers will determine that, but it certainly seems moderate. Are there any outliers? Oh, what's the form? What's the form?
Linear.
Looks linear. In our class, it's either linear or nonlinear. We don't specify anything else. And are there any outliers? Any numbers that are so far outside the general pattern that we question our own existence?
I mean, 3231 could be an outlier, but
Yeah, but it's hard to tell, right? But maybe it is, but it's not so easy to determine that. Right? If you draw a line, something like that, maybe it is, but right? But doing it by eye is tough. Guess the value of the correlation coefficient R. Guess the value. What can you tell me about R for sure?
it's between -1 and 1.
In general, yes. But here, you can narrow it down more.
Oh, it's between 0 and 1.
It's between 0 and 1, because it's on the way up. Now, we know that a strong correlation would have an R value near 1, and a weak correlation to the point that you're not even sure there's a line would be near 0. This is moderate, we said. So roughly what value of R corresponds to a moderate situation?
Is it like around 0.7 or 0.8?
Yeah, around 0.7 or 0.8 would be moderate. Yeah, that's pretty good, because 0.8 will give you an R squared value of 0.64. So yeah, okay, so 0.7, something like around there, 0.75, it's a pretty good guess.
Yeah,
Okay, what are the units of R?
there are no units.
Excellent, there are no units. R has no units. Now, the actual value of the correlation coefficient is claimed to be one of the following: 0.3, 0.5, 0.7, or 0.9. Which one do you think it is? This is based on what we just said.
0.7.
Yeah, I'd have to guess 0.7 myself. Certainly seems reasonable. Let's go ahead quickly. We have our calculator, so it shouldn't take more than 2 minutes. Let's go ahead and do it on the calculator. How would I do it on the calculator?
Go to stat and then put edit.
Okay, stat edit. What do I put in the first column?
You'd put your explanatory variable, I think.
Okay, excellent. The explanatory variable, which is the first column. Okay, that takes care of the first column. And now the second column. Okay. Make sure your frequency list is empty because we. Oh, hello. Okay, I got it. What's your R, everyone?
I'm still inputting the numbers.
Okay. Okay. What do you guys get?
I got 0.699.
Yeah, me too. 0.699080864. So we really got something very close to 0.7. That means our estimate was pretty good. G. If we change the units of flight distance from miles to kilometers, how would that change the scatter plot? And how would it change the correlation coefficients? If we changed it miles to kilometers, how will that change the scatter plot?
Wait, if you, sorry.
No, go ahead.
Oh, I was gonna say if you just changed the units or if you converted it from miles to kilometers.
I would assume converted it from miles to kilometers.
Okay.
I believe the graph would just change, but the correlation coefficient wouldn't change at all.
That's correct. The correlation coefficient does not depend upon units. So if you change the units that you're using for the same quantities, it would not change. As for the scatter plot changing, if you change your scale, so instead of 500, it's 0.5, then the scatter plot wouldn't change either. You're just changing your scaling factor. So it's a little vague of a question. If you keep the same scale, of course, your graph will change. But if you don't change the scale, I mean, if you allow yourself to change the scale, it'll be exactly the same. But either way, the scatter plot, the correlation coefficient will not change. And if we interchange the X and Y variables, how would that change the scatter plot and the correlation coefficient?
I believe the correlation coefficient wouldn't change at all still. It would just be of course, the scatter plot would change.
Yeah, the scatter plot would kind of flip over a 45-degree line because your X and Y values are changing. But the correlation coefficient, which is just how they're correlated, not cause and effect, just are they connected, would not change. Question 2, match the diagrams with the following correlations. So let's start with the one at the top left. Of those 6 numbers, which one's the one at the top left?
1.
That's a hopefully a no-brainer. So 1 is out. How about this one down here at the bottom right?
Negative 0.93.
Negative 0.93. It's very strong, but negative. Okay. Next highest number is negative 0.75. So we're looking for something also negative, but not quite as strong as this, more moderate.
Bottom left.
Bottom left. Next highest number is 0.63. In fact, of the remaining 3, it's the only one that even shows any linearity at all, because these are very weak.
The bottom middle.
Bottom middle. And then we have these two, which is 0.27 and negative 0.2. Both very weak, but this one is at least a positive tint, where this one is negative.
I think top middle looks kind of positive.
Kind of positive. And would you say this is kind of negative?
Yeah, I guess.
I guess it's tough. When it's close to 0, it really is tough to see. I would not give you a question like this because I don't like asking any questions that have any vagueness at all. And so that's just not good. But yeah, of these two, this one at least has a semblance of it's kind of going up. And this one, by the way, it's smaller. It's closer to 1. Sorry, closer to 0. I don't even see any going down. And at least here, I kind of see it going up.
Yeah, it looks just like a blob of.
Yeah, it's like what's it called? A Rorschach test or something like that? What are those called? Any psych majors here? What are those called? Rorschach tests? You know the ones I mean? Like where you.
I know what you mean, but I don't know what they're called.
Yeah,
Like,
but you know what I'm talking about, right? Anyways, okay.
those images where you just see stuff.
Yeah, exactly. What do you see here? Yeah. Okay. Question 3. Does the scatter plot at the right show a relationship between the two variables? Is there a relationship between aspirin and relief?
There is, but it's non-linear.
Yes, there certainly is. It's just not linear. So why is the correlation coefficient 0 if there's a relationship?
Because it's not linear.
Because it's not a linear relationship. That's exactly it. Correlation coefficient only measures linearity. 4. The scatter plot below shows the annual mortality rate from 58 to 64 and the calcium concentration in the drinking water supply for a random sample of 61 large towns in England and Wales. Each point represents a what? Each point is a what?
Is it the number of deaths per 100,000?
Well, that might be where that point lands on one of the two scales. But what is the point itself?
Represents a correlation between mortality rate.
Each point is a town.
Oh, okay.
Each of these points is just one of the towns, right? It has a numerical value on this scale and one on this scale, but the points themselves are the data points, not the variables that we care about. The data points themselves, these are towns. Anahit, does that make sense?
Yes.
So summarize the key features. Direction,
Negative.
negative. Form,
Linear.
form linear. Strength,
Weak.
weak to moderate. I mean, I certainly see a linear trend here. And with weak, you really question whether there's one at all. Like the last example here, this is weak. This is moderate, right? I can see it, but it's kind of spread out. Here, can I see it? Maybe. So here, I certainly see a downward trend. So weak, moderate. Any outliers?
Maybe, we don't know.
Maybe, but nothing stands out, right? Nothing, like if I had a dot here, I certainly say, hey, wait a second. But these ones here, I mean, they're not so far off the beaten path that I would say they're an outlier. What does the plot tell us about the relationship between calcium concentration and mortality?
The higher the calcium concentration, the lower the mortality rate.
Certainly seems that way. Doesn't tell us that a higher calcium concentration causes lower mortality rates. There's no cause and effect. That's not how statistics rolls. But there certainly seems to be a correlation between calcium concentration and mortality. As this one goes up, this one goes down. All right, chapter 5. Least squares regression. So Jose's cell phone plans requires him to pay a monthly base amount, $10, plus 30 cents per minute that the phone is in use. In a scatter plot of Jose's monthly bills, ignoring taxes and other fees, all of the points would fall exactly on a line. Plot this line using minutes as the x-axis and monthly bill as the y-axis. So let's make sure we understand why this would all fall on a line. So if you don't use your phone at all, how much is it costing you?
10.
$10. So if this is a height of 10,
The y-intercept.
yeah, it's your y-intercept. Now, up until 1 minute, it's going to cost you how much more?
0.
Well, it's 30 cents per minute, correct?
Yeah, but if you haven't used the minute yet.
I think the way plans work is that as long as you jump into the minute, they're going to charge you for the whole thing,
Oh, okay, 30 cents.
right? So 30 cents. Okay, so once you're in the minute, now you're going to be along this line here at 10.3. The next minute is now at 10.6. And the next minute, it's now going to be at 10.9 and so on, correct? Do you agree?
Yes.
Okay. So when he gets his monthly bills, this is for one bill. One month, which means his bill for that month is going to be 10 plus 0.3x, where x is how many minutes he used and y is the bill, correct?
Yes.
Correct.
This formula is going to hold no matter what x is, which means it's a graph of a straight line, y equals mx plus b. So every x that I have, I plug into that formula, out pops y in a very predictable way. There's no randomness. If I know x, I know exactly what y is going to be. There's no randomness whatsoever. Because of that, all my points are going to fall on a line, because the only reason they'd fall off the line is due to randomness, but there is no randomness. It's exact. So every bill would have an XY relationship satisfied by this formula. Does that make sense?
Yes.
Okay, which means R is equal to what here?
1.
1. R squared is equal to what?
1.
1. Now, recall the flight distance airfare example from the last time. We will now use this data set to determine an equation that will predict the least expensive nonstop airfare from Los Angeles to any city. So we should have this still in our calculator. What variable does y represent in this example? What was our y in this example?
Y is the monthly bill.
Not this. We're going back to the airfare.
Oh.
It's okay. What is I? Huh?
Why miles?
Remember, what caused what? Did miles cause cost, or did cost cause miles?
No, it was costing, right?
So cost was the y variable, right?
Yes.
And miles was the x variable. So let's calculate the best fit line. How do I do that? What is the best fit line?
Y equals mx plus b.
Okay, so what is the m and the b?
B is 115.56.
Okay, we'll just say 1 to 16 just to round off, even though it's never a bad idea.
And then A was 0.09 if you want to run.
Yeah, just for the sake of this example, we'll round it here. I mean, I would certainly keep a few more decimals on my own work, but just for the sake of rounding. So the best line from the calculator is y equals 0.09x plus 116, where this is a x plus b. What does b represent physically? This 116 means what exactly? How would you interpret that number 116?
Y-intercept?
No, that's I mean, that's true, but that's a generic answer. I'm looking in the context of this problem. What would the 116 represent?
Would it be the number of dollars you start off paying?
When you say start off, be a little more specific.
Your upfront cost, like that's how much you're gonna pay
If you do what?
if you don't go anywhere.
Okay, yes. If you don't go anywhere, if the distance that you travel is 0, it's going to cost you $116. Now, does that make sense?
Yes.
Really? If you don't go on a flight at all, it's going to cost you $116?
No, it makes sense in response to the equation, but it doesn't.
But does it make sense as a practical matter?
No.
So can we explain this absurd conclusion based upon our data?
Like mathematically?
No, just practically. Well,
No.
yeah, I meant mathematically, but I'm not looking for actual math. I'm looking for an explanation from the class.
Well,
What's
no.
a one word explanation for how this came to be? I'll give you a hint. It starts with the letter E. It ends with the letter N. I feel like I'm playing. You know what? Let's have some fun. Hold on a second.
Hangman?
Yeah. Uh-oh, ran out of room. Hold on.
Start off with vowels.
Okay. Go ahead, pick one.
A.
A.
N.
And what a genius. How do you figure that one out?
Lucky guys.
Okay, that's it. Next.
Does that
R.
What?
R.
Did someone say X? Someone texted me X. Unbelievable. If you know the word, say it.
T
R. T. I heard
or
R.
extra.
Extradition.
Extradition. No, it's not extradition. which doesn't have an AT.
I. O.
Reaction.
Extrapolation.
Extrapolation. I guess there was another O there. Sorry about that. Extrapolation. The data doesn't extend to x equals 0. The data starts at x equals what? What's the lowest x value? Where did how did it go? Oh, it's way back. What's the lowest x value? The lowest x value was 236, correct?
Correct.
You can't extend your line outside of the range of the data values. That's a big no-no. So in this case, the problem is that you try to extend your line all the way, where am I going? All the way to x equals 0, but your data does not extend that far. Does that make sense?
Yes.
Right?
Yeah.
Don't extrapolate. Don't go too far. You're not allowed to. Now, what does A represent? What does this 0.09 represent?
Or but like your slope.
Yes, but in the context of this problem, what does it represent? Be more
Oh.
specific.
Cost per mile.
Huh?
Would it be your cost per mile?
It would. So for every mile further, it should cost me 9 extra cents. Right? How much does the cost go up as the mileage goes up? My slope. For every 1 mile increase, my cost on average increases by 9 cents. That's exactly what it is. Does that make sense?
Yes.
E. The correlation between flight distance and airfare was 0.7. We calculated that. Here are some other statistics: SY, SX, X bar, and Y bar. It says use the following formulas to calculate B and A. So if we have R is 0.7 and we have SY is 100 and SX is 792, we should have no problem pouring it into this formula to calculate B. Let's go ahead and do it very quickly. 0.7 times 100 divided by 792 is 0.09. Of course, they're calling that B, we called it A, so we're just switching the letters. Okay, not a big deal, because if you look in your calculator, A plus BX and B plus AX, it does both of them. We just did it the other way. And then their formula, by the way, for the second one is wrong. Can anyone tell me why it's wrong? It's more of a typo than anything else, but why is it wrong? Should be Y bar, the average of the Ys. There's no such thing as just Y by itself. Silly typo, but it is a typo nonetheless. This should be Y bar. Ooh, that was straight. So I just did it on my calculator and I got 0.088 for this one, which is pretty close. And I got 116 for this one, which is pretty close. So our A's and our B's are just backwards, yes?
Yeah. Is the equation going to be given, or should we have that somewhere?
I'm not gonna ask any question like that
Okay.
on this test. I mean, I'm writing the test, so I'm not gonna ask a question like that requires those formulas. And the only way I would is if I provide for you a formula sheet with well, wait a second. Isn't it open book, open notes?
Yeah, it's open book, open notes, but just wants to know.
Yeah. I mean, yeah, write them down. I mean, I just said I'm not gonna do it. But if I forget when I write my test, which I'll have to do tonight, I mean, have them down somewhere, but I've never asked it in the past, and I don't think I'll start now.
Okay.
Okay. Yeah. So theirs is A plus BX. Oh, actually, that was the same as ours. 116 plus 0.088x. Okay, so our A's and B's was the same as theirs. Sketch the regression line on the scatter plot. How am I going to do that on my calculator? How am I going to sketch the regression line on my calculator?
Press Y equals.
Y equals, what am I going to put in there for Y equals?
The equation we wrote down earlier, I didn't write it down, but we wrote it down earlier. It's up on top.
Okay. And is that all I have to do?
You have to put graph, I believe, and then
Is that all I have to do? You guys should remember and have written down what you need to make a scatter plot.
the window.
You got to change your window because these numbers are in the thousands. Right? These
Yeah.
these numbers are in the thousands. So you want to make sure your window is big enough to get them all. And yeah, so I just did it. That's good. Whoops. Okay, so I just kept changing it a few times. I just did it, changed the window, ended up getting a scatter plot that looks like this. So you should certainly know how to do that. And we already did part G. And we already did part H. So now finally, why do we actually compute this best fit line? What's the point? So this is question I. Using the equation of the least squares regression line, predict the airfare to Ohio, where the distance is 1911 miles. How do I use that line to predict the airfare at 1911 miles?
You would set the equation to 1911.
Wait a second. Isn't X miles and Y dollars?
Oh, never mind. Then you plug in 1911 to the equation.
Plug in 1911. Now I actually did it on the calculator very quickly. I did second calculate, and I gave it a value of 1911. What pops out when you do that? On your calculator, second calculate, and then give it a value of 1911. What does your calculator give you? Anyone?
What was the equation for y again? I didn't write it down.
I did y equals point. Well, you can always look back in your calculator to get those numbers, but I did y equals 0.088 x plus 116. So your calculator should look like this. On the bottom, I plugged in an x value of 1911. When I did second calculate, and it gave me the y value of 284 point, whatever that says. I can't read backwards. 284.168? Yeah, 168. Of course, I can do it by hand, but you have a calculator, so what's the point? For J, predict the airfare to Missouri, which is 1369 miles. What does my calculator give me for that one? Anyone there? Hello.
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 So is anyone there?
Yes.
So what does my calculator predict for one of these things? Is anyone doing it?
Was it 1588 or
For which?
actually it's I plugged in 1369.
Yeah, what do you get?
I got it's 158,804.
Wait. What's your y equals? What's your equation?
I think I put 0.088 plus x 116. Did I put?
Wait, 0.088 plus x plus 116?
Oh, okay. I put the my fault. Let me check.
What do you, did I hear plus x?
Yeah, I didn't put it in right. 1 second.
Okay. Ow.
Okay, now I got 236.472.
That's it. What's the Airfare for 5484 miles?
$598.592.
And
Is it outside of the?
yes, it is.
Okay.
Can extrapolate. I mean, your answer is correct, but is the prediction reliable? The answer is no.
Okay. Yeah. I just didn't know. I know we should have checked that, but I wasn't able to check because
Yeah.
I don't have it up right.
Gotcha. But yeah, that's it. Right? Predictions for values of the explanatory variable that fall outside the range in the data are not reliable and should be avoided. This type of prediction is called extrapolation. So that takes us to the end of 5. So a lot quicker than the last one. We did 4 chapters today. And I know in the beginning of the course, I think we did the first 2, but I don't think we did the third. So let's do that now. Right? I think we did all this. Either way, normal distribution, very important. It says draw 2 normal curves, and this is chapter 3 now, page 28. Draw 2 normal curves on the same axis below that have the same SD and different means. How would I draw 2 curves with the same SD and different means? What would they look like? Same standard deviation, different means. What would they look like? 2 normal curves, same SD, different means.
They just start off at different points, basically.
Well, normal curves go forever in both directions. So
I mean, the midpoint, like the.
yeah, exactly. Here's one. Here's another. Within the limits of my artistic abilities, they're the same spread, but their means are different. Same spread, just different means, huh? So what are the similarities? Well, they look the same. They have the same width, same height. They curve down the same places, but their centers are different locations. Now it says draw 2 curves on the same axis that have the same mean, but different SDs. What would these look like?
The midpoint will start at the same place. It just won't be wider than the other.
Wider and?
Or narrow.
Order.
Well, wider and shallower. Okay, because remember, the area under the curve has to be 1. So if one of them is wider and there's more area on the left and right, it better be shallower to compensate.
Okay.
Does that make sense?
Yes.
Okay. A famous test of human intelligence is the Wechsler IQ test. The IQ scores follow a normal curve with mean 100 and SD 15. Carefully draw this normal density below. Carefully draw. I don't know what they mean by carefully, but there's my thing. That's horrible. Oh my God. So what's here in the center?
100.
100. How do I locate one deviation either direction?
Where it shifts from a tail to a ball, you said?
Yeah, give or take. So right around here or so. That's 1. That's 2. Oh, that's 2, 3, 1, 2, and 3, and so on. Hard to do on the computer or by hand in general, but hopefully you get the idea. One deviation up and 1 deviation down, and so on. Hopefully that's clear. We did spend a lot of time in the normal. 2, the histogram below shows the distribution of the weekly changes in the price of Apple stock for the 10-year period ending March 20, 2014. A normal curve has been fitted to the histogram. Use a normal curve to estimate the mean weekly return on Apple stock during this period. What is the mean weekly return on Apple stock during this period? What is the mean weekly return? How do I find it?
When you just like add them all up and then you,
No. We have this normal curve. We don't need to look at the individual columns anymore because now it says use the normal curve. How do I find it from the normal curve?
Find the one that's closest to the high point of the normal curve.
Okay, well, there's the high point. So what is that?
11.
It looks like 0.18%.
Sorry. Yeah, that's what I meant.
I believe you. So 0.18% seems to be the mean weekly return. Yes?
Yes.
Okay, now, of course, if I wanted to go back to my original data and calculate it that way, I could, but the whole point of the having normal is to simplify my work. As accurately as possible, mark the inflection points, that's the change of curvature points, or what I call the hill to bowl points, on the normal curve. So as best as we can, where are those points located? Stop me when I get there. I'm gonna move a little bit of time. Stop me when I get to the hill to bowl change.
Probably like right there, somewhere on.
Okay, give or take. And its corresponding counterpoint on the other side. Estimate the standard deviation then. Well, if this is the mean, then that's the standard deviation. So from 0.18 to 5.69%, that's about what? 5.41% will be the deviation. That's just an estimate. Does that make sense?
Yes.
Okay. See, this stuff's not that bad, right? 4, suppose the scores on an achievement test follow an approximately normal distribution with mean 500, min 350, and max 650. Which of the following values could be the standard deviation? Which of these is reasonable? So we have a normal curve. How do you guys draw on this thing? So the mean is 500. The min is 350, which is 150 down. And the max is 650, which is 150 up. What is a reasonable stop? Someone said stop. Wait, someone told me to stop. Michelle, what am I stopping?
I think that was like when you were putting the dots on the graph.
Oh, sorry. Sorry. I'm like, what did I do wrong? Okay. Sorry. Okay.
Would that be 50 for the value?
So the question is, what is it, right? So here's a general rule of thumb. If you take the entire range, which is how much?
$300.
300. The general rule of thumb is that the standard deviation should be approximately the range over 4. 1/4 the range. So it should be about 75. So really either of these two numbers are ballpark values as possibilities because they're both, same distance from 75. Five, students' GPA at a certain university are approximately normally distributed with mean 2.5 and deviation 0.5. So N of 2.5, comma, 0.5. What percentage of students are between 2 and 3? Let's do it with the calculator. Okay, I have the answer. That's literally how long it should take you at this point. We've done normal so much.
Do you even need a calculator for that one specifically?
Well, you don't need one, but of course the calculator is just pretty quick. But to be honest, if you see how to do it, it's faster than the calculator. What should the answer be?
Wouldn't it be 68?
Yeah, 68%. It's one deviation either direction. My calculator gave me 0.6826894,809. So my calculator did give me 68%. How about from 1.5 to 3.5?
That's 2 deviations, so it'd be the
95?
95%. Now, how about below 2?
that's when you need that calculator.
Well, you don't need it, but it certainly makes it easier. The reason why you don't need it is because we know that 2 is 1 deviation down, right? So we're looking for this area here.
Yeah.
So I know that the 1 deviation 68%. And therefore, this one here is going to be 16%. Because it's half of what's remaining. If the middle is 68%, the other half is 16%. Correct?
Yeah.
Yeah, I mean, calculator makes it easy too, but you don't need the calculator. How about 3.5 or higher? Uh-oh.
2.5.
How much?
2.5.
I think I know where you got that from. Can you explain why?
I got it from the number top, so it was 95% for 1.5 to 3.5.
Oh, that's right. I thought 2 was a mean for a second, but you're right. You're past 2 deviations, right?
Yeah.
So it's going to be 2.5%. That is right. I'm sorry. I was thinking of something else. But you are right, because the 2 deviations, 95%, leaving 5%, 2.5% on each half. That's exactly it. Very
If
nice.
you were to like round it without just to be considered wrong.
No, like on my calculator, I just did it and I got 2.275%, which is
Okay.
obviously more accurate, but I'll accept either one.
Okay.
Okay. And that's it. Those are the types of examples you'll see for that. So let's go back now to another chapter, chapter 2. I know we did some of this stuff already the first time around. I remember it vividly. All right, come on. Yeah, I definitely remember doing this first one. So yeah, chapter 2 was measure the center and spread, 5 number summary. Okay, so chapter 2, let's find it. 2, because we definitely did number 1, so you'll find it in one of the videos. And I think we might have done 2 as well. But just in case, I remember we did that for sure. So let's do the standard deviation now. The data below shows the ammonia levels in parts per million in air samples taken near the exit ramp of the San Francisco freeway tunnel for 8 days during the afternoon drive. 8 data points. Complete the table below. So for example, they've already calculated for us the mean. They were very nice. And the mean is 1.47. So how far is 1.55 from the mean?
0.08.
0.08. So if I square that, what do I get? 0.8 squared is 64, 4 decimals, so 0.0064. So I can fill out this table and square them all and add these together. So let's do it. 1.41 to 1.47, how far?
Negative 0.06.
Negative 0.06, 6 squared is 36, 4 decimals, so 0.0036. And how far is 1.48?
0.01.
0.01 squared is going to be 0.0001. So when I add these 3645, 145, 161, 221, 246, 282, 283. So so I get 0.0283. What do I do with this number?
We can't see the bottom of the graph.
Oh, really? I'm sorry.
I don't know. I think it's just like the bar for zoom on the bottom.
Wait. If I rise it up, how's that?
Yeah, that's better. It was
Yeah.
just
Yeah. Can you see it all now?
I need a little bit higher, I think, because you can't see the bottom, the very bottom part.
Okay, hold on. Let me. I don't know. I can raise it, but unfortunately, I can't raise my numbers with it.
Yeah, sorry about that.
No, it's okay. So I got, well, my final answer was 0.0283. That's really the one that matters. The other ones you can get pretty easily. So what do I do with this number 0.0283? Oh, wait. I can select these. Oh, cool. That's gnarly. Okay, I don't know how to raise it though. Oh, there we go. Hello. Something new every day. So cool. Okay, look at that. Come on, a minute. That was pretty cool. Okay, don't admit it. Fine. All right. So what do I do with this number? Sorry, did someone say something just now? Hello?
Square it.
Nope. Remember, you just added up all the squares. You squared each one of these and you added them all together. You just calculated the sum of x minus x bar squared. What do I do now to calculate the standard deviation?
Then would you divide all that by 9?
Not
mean by 8?
9, by 8.
8.
And then what do I do with that number? What do I do with that number? What's the end of the formula? After squaring, adding, and dividing by 8, what do I do next?
Do you do 0.0283 for x?
No, 0.08283 is what I got after I squared them all and added them all together.
Okay.
Right? I squared each one, I added them, I divided by 8. When I get that number, what do I do with it?
Divide by 8.
What's the formula for the standard deviation? Wait, 1, 2, 3, 4, 5, 6. Oh, it's not 8. I miscounted. What number should it be?
1, 2. It is 8.
Well, there's 8 data points, but you don't divide by the number of data points. You divide by one fewer
Oh.
number of data points.
You square root it?
You square root it. I thought there were 9, which is why when you said 8, I'm like, oh yeah, she got it. But there were 8, so it should have been 7. So the standard deviation is 0.0635. That's just what you get. Okay? Know that formula. Which one of these has the larger standard deviation? Score 1 or score 2? No math required.
2?
Why? Not saying you're wrong, just why?
Because it looks like
It looks like what?
more people scored higher.
Because it looks like what?
It looks like more people scored higher on the second one.
Yeah, they did, but why does that mean the standard deviation should be higher? So the reason that the answer is 2, you were correct, is because on average, most of the data points is far away from the mean. Whereas here, most of the data points are closer to the mean. The higher standard deviation is the one where on average, the data points are further away from the mean. That's why 2 has the larger standard deviation. Does that make sense?
Yes.
Okay. And for this one here, which one has the larger standard deviation?
Would they be the
Yeah, they are the same. Because they're just flipped, but the spread of the data is exactly the same in both cases. And 3, consider the following samples of student scores in a 7-point quiz. Without doing any calculations, answer the following questions. Which sample has the greatest standard deviation? 1, 2, or 3?
Me?
Sorry, which one?
1?
Is that what the first person said? I just didn't hear.
I'm not sure what the first person said.
Oh,
Oh,
okay.
I said 2.
So 2 is correct.
Oh,
All the data is far away from the mean. 0, 7s, the mean's right in the center of 3.5. Which one has the smallest standard deviation?
The third one.
Exactly, because most of the data is at the mean, so very little of it's on the outside. Well, 2 is the largest, 3 is the smallest. And that takes us to the end of 2, and we did the rest. So that takes us to the end of the review. We did a lot today. What do you guys think? How do you feel?
I feel like we did do a lot.
This was great. What a productive day this was. But how do you
Are
guys
we
feel?
sarcastic?
Huh?
I feel like you said that sarcastically.
No, not at all.
Oh, okay.
No, I'm serious. I think it was a very good day. We did
I was gonna
2,
ask-
3, 4, 5, 8,
8 and 9.
9.
Yeah.
We did. That's great. That's great. That's wonderful. That's wonderful. So,
I have a question. Do you know
Yeah.
where the test is going to be or the exam?
do I know what?
Do you know where the exam will be?
Oh, yeah. I got an email today about that. Hold on. I got an email today about that. It's right here. Dear all, we got you a bigger room for your on-campus exams. The new room is in solar. So please inform all students. It's Live Oak 1117. Live Oak 11, not 117, 1117. Live Oak 1117.
Okay.
That's the first building, Live Oak, first floor, room 17, 1117.
Great.
Now I will be coming. This is a 6:30 class. I'm gonna have to drive there from my other school, whose class ends at 5:40, which gives me 50 minutes to get there. Should not be a problem. I should be there with plenty of time. What room? You're kidding,
You
right?
just said it, 117.
Okay. Now I have to be sarcastic about that one. I'm sorry, but yeah, I just joined my B. I just joined my B.
My bad.
Wait, Nelson Gonzalez. Who the hell's Nelson Gonzalez? You in my class?
Yeah.
I don't ever ask
Where
for
you been all
Nelson.
semester?
I haven't said the name Nelson once. What's your name on the roster?
Nelson Gonzalez.
Are you sure?
Yeah, you take attendance every single time and I stay here.
I see Nelson. Hold on. Oh shit, he's right. What the hell? Why do I have no recollection of ever saying the name Nelson? Woo, that's embarrassing. Well, sorry. Sorry. I'm sorry about that.
Recording that? You're
No,
recording? I'm sorry as well?
I paused it right before I said it, so none of you can prove anything. So when will the recording be posted? It should be posted in about 10 minutes. As soon as I close the Zoom down, my computer has to process it, and then I put it on YouTube, and it takes like 10 minutes for that to go through. So it's usually about 15 minutes after classes when it gets up there.
Is there like a link to them?
Yeah, it's all on Canvas.
Okay.
Yeah, under announcements, you can see all my videos.
Thank you.
And they're all labeled Math 140 Business, Lecture 1, 2, 3, and so on. So they're a little easier to find. But sorry, Nelson, yeah, it's just like the name Nelson. I'm like, who is that? So I'm really sorry about that.
It's all good.
Anyways, other than that, study hard this weekend. It has been a very long day. It's been a long life. What can I say? Study hard this weekend. The book is a great resource. If you're not sure about something, read the book. It's always a good idea. The videos, you're free to, of course, watch the videos. Watch YouTube. You know, if there's an idea that you're not getting, go on YouTube. 1,000 people have made videos on it. And sometimes, you might not get it from me or the first video you watch or the second video you watch, but then it's like, oh, and it all clicks because someone says something in just the right way that works for you. So, that I do that all the time when I'm learning new topics. And I'm not getting it from whatever book I'm reading. I'll go online and look and find someone who's talking about it. And sometimes it's not the first. It's just that's the way it is. But yeah, study hard. I look forward to seeing all of you. Don't forget to do that whole health screening thing that must be done the day of the test. Otherwise, they won't let you on campus. Bring an ID. Scantrons are not required. It'll be multiple choice and yeah, hold on. Yeah, multiple choice and short answer. And that's it. So yeah, good luck. I'll see you then.